Up until this point, we've had a silent game, kind of boring because of that, and a little bit lame, like, hello, where's the sound effects? Where's the music, right? So in this episode, we're going to build an audio system that's going to support music, sound effects, UI audio, as well as separate volumes for each of those, the ability to play things back from anywhere in any of your scripts. So it's nice and modular. You don't even have to add audio players to these nodes if you don't want to. And we'll even add the slight reverb that you can hear with the ability to change reverb between levels. We'll even have music transitions as you go to different scenes as well. And if that weren't enough, we'll also have the ability to save and load the user settings. So if that's interesting to you, then stick around and I'll show you my complete solution. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GDScript. This is the Metroidvania Forge. All right, welcome to this video. I've kind of saved one of my favorite ones for the end, and this is adding audio. And I've also kind of taken an approach with this project where we're introducing the audio fairly late in the game. And I think it's because I've had this system and concept-based approach to a lot of what we've done so far. Whereas with audio, we're starting to get into some of the detail. But that being said, this video is going to be focused on a system or high-level overview and implementation of an audio system, because what we want is we want to be able to have kind of some good rules and practices in place for our project that will allow us to really easily implement the audio in the future. So what we'll do is we'll build that system, much like the audio bus or our save manager or other things. We're going to build a global scene to help us work with the audio, and it's going to be useful for a couple things. We're going to use it to play music as we change from scene to scene, or even on our title screen. We'll use it to be able to play audio here in our UIs, which, oh look, I added this black box for my map. I got to change that. But, you know, so we have some sound effects when we're selecting and canceling and pausing and that kind of stuff. A way to streamline that, because that can get really tedious when you're just having to, like, every time you add a button, you got to add a listener and then you got to hook it up to a sound. It's like, come on, it's got to be the same for all of them, right? So I have a solution for that we'll introduce. And we'll also introduce a way to play 2D spatial audio in our game world using this new global scene manager. Now, that's not the only way that you can play audio. Obviously, we can put an AudioStreamPlayer on in our player scene or enemies or any other entity in the game and just play back audio from there. But sometimes that's a little bit overkill as well, because maybe you have something that just needs to play a couple commonly used sound effects, and it's like, you know, why add these nodes and add a bunch of stuff when you could just, with one line of code in a function, just trigger something from our global audio playback. And so we will cover those three things. We're also going to introduce some fun things in this video, like a way to introduce reverb effect. Obviously, these different dungeon rooms might have a different kind of spatial reverb audio effect that we could apply to give it some unique flavor. We'll have audio on things like our doors and switches and responses when we save our game. And it's really going to add a lot of polish, okay? But more importantly, it's going to add, again, that base foundation that we need to make good decisions about implementing or playing back audio in the future. Okay, let's start with some of the typical setup kind of stuff that we generally do. So this is going to be a global scene. Sorry, I'm just going to close a few things real quick. So I'm going to come in here to my global folder, and I'm going to add a new folder. Let's see, create new folder. There we go. And we'll just call this audio. Now, one thing about this approach that I'm taking, in the past when I've built systems like this, I build a global script, and it's just a script and it can kind of do everything from code. Now, technically, we could do that here. We could just build this and use just code to instantiate the different audio stream players that we need and things like that. I think there's a good benefit to using a global scene for this one, partly because I think it's a lot easier to learn about these nodes when we have the node in the scene and we can click on it and inspect it. It also just seems to be a little bit easier to work with. It removes some of the code that it just becomes a little bit of a pain to add, you know, when we can just drop something into the scene tree. So let's go ahead and create a new scene in here, and I'll call it audio. Now, in addition to this, I'm going to add a folder here in our audio for our UI audio playback. So I'm going to call it UI audio. And inside this folder, we're going to plop some sound effects. So let's go ahead and just open this in our file manager. And then again, if you're following along and want to grab the assets from my itch.io page for this project, you can grab that. Otherwise, you'll need to find your own versions of the audio. But that itch.io content is free if you're new, so don't stress about that. I get people asking why I charge. It is an optional donation if you feel like this content is worth it. And obviously some of you might feel that way, but not feel like you can financially support me, and that's okay. I've made the choice to give it away for free. So here I am in my Chapter 3 Game Systems assets. I'm going to go into the audio file and grab these WAV files with the prefix of UI on them. I'm just going to copy and paste them here. And while we're doing this kind of stuff, let's do a few other things. Now, in previous episodes, you would have grabbed the icon that we're going to use today. So this music trigger, make sure you've got that in your icons folder in your project. And we can see that I should have that if I go up here to my root resources folder, the root folder of the project. In general is where I've added my icons. So yeah, you can see that. And I've got a music trigger right there. Now, another thing that I want to do is in the root level of my project. You could do that from here, or you can do that in Godot. I want to add a folder for the music files that we're going to use to play back the different music tracks that we'll play for our levels. So create a new folder and just call it music. It's easier to do it from here sometimes. Okay, so I've got my music folder, and then from the zip file, there's a music folder here. So you could just copy and paste that whole folder into the root of your project if you want. But I'm going to bring in, these are 3 audio tracks. They're somewhat looping. They're not super perfect or refined, and they're not great tracks. These are some audio tracks I kind of wrote and produced in LLMS, for those of you who are familiar. But I'm not much, I mean, I like music and I like trying to create it, but I'm not great by any means. So, you know, take it or leave it. But it's something to work with if you don't have your own yet. So I think that's going to encompass everything that we need to bring in for this episode. We've already dealt with all the sprites, music, icons, fonts. Yeah, we should be good. Whew, okay. So just to give you an example, we've got like a title screen, piece of audio here. Okay. And then we've got forest and dungeon music tracks. We can play these in our various levels. And one thing that you'll note about these are OGG files. I think that's a preferred file type for music playback. I'm going to actually select these though and go to import and make sure loop is on and then re-import them. I wonder if that applied to all. Yeah, it did. Okay. And we want it to be looping because these are music tracks and they should loop. And this is the way that you set a audio file to play back in a looped manner. If you have a WAV file, you can do that same setting. So like if we look at our UI audio in here, you can see that it's a different configuration because it's a WAV file. They've got different options. Loop mode for WAV files by default is detect from WAV. And because I'm a little bit less experienced with some audio stuff, I don't know how to set up a WAV file to say that it's looping. So maybe if you're a knowledgeable expert on that, comment and give me a hint in the comments below. Maybe we'll make a video about that. But otherwise, detect from WAV is fine. You could disable it. You know, most of these things, this UI audio, you do not want looping, right? But otherwise, you've got settings in here for making it mono or normalizing the audio would mean like the volume level of it. So you can see that normalize it so that its peak volume is at 0 when enabled. It will make some audio louder and other audio quieter, and just things like that. For the most part, I think these bits of audio are relatively appropriately balanced. But again, I'm not an audio expert, so you're not going to have perfect audio out of this. I do wish there was a normalize option on these OGG, but it doesn't matter too much. We did have a few other audio effects that we brought in the previous video. So if you didn't follow that one and you want to grab those, you can. But if we look at in my general folder, if we look at our door and switch, we've got this door crash and door switch audio that we're going to utilize today as well. Okay, so with that, we've got a new scene set up. We've got our audio brought in, made sure that we set up our music to be looping because that's going to be important. And I think we're ready to rock and roll. Okay, let's set up this audio node and figure out how this needs to work. I'm going to change the type of this. I don't want it to be a node 2D. I don't think that's necessary. So let me just change the type to a regular node maybe. Now a regular node, you'll note, has no position. It's just got process mode and things like that, okay? But our child nodes may need position. But what we're going to add to this as actual children right now is I'm going to just add some audio stream players. Now there's two primary types. Well, there's three, right? We've got a 3D audio stream player, which we're not going to be using. And then we have a 2D audio stream player, which we will use, but we're not going to add any to the scene. And we've got a regular audio stream player. See, the difference between each of those is how many Ds they've got, right? This one has 3 and this one has 2 and this is none. What this means is obviously this is spatial playback in a 2D space. So that means if you have an audio stream player 2D playing a sound on the left side of your game world, it's going to come in through your left ear, and same with the right, or if it's centered, right? So it's got spatial audio in that way. And obviously 3D is the same, but in 3D space. So distance plays a role in both of these as well. So an audio stream player that's further away will fade out and eventually not play at all. But then a regular audio stream player like this one, which we're going to go ahead and start with, it has no positional characteristics. It just plays audio, at however you tell it to play. There's no positional nature to it. It just plays what it plays. So we're going to use these for our music and UI because those aren't positional. Then anything that we do positional is either going to be attached to a node, which we're not going to do in this video, or we're going to dynamically create a 2D audio stream player and position it where the audio needs to be. Okay, so that it maintains or utilizes that 2D nature of the audio stream player 2D. Okay, so with these, we're going to have a couple of these. I'm going to call this one music. And this system, we're going to essentially support 2 music tracks. So I'm going to call this music 1 and duplicate it. So we've got a music 2. Okay, now we're going to have to come back to these, but generally they don't need too much as far as configuration. Okay, we are going to come back and change this audio bus in a step here in just a moment. But in addition to this, I'm just going to go ahead and configure basic nodes. So this third audio stream player is going to be for our UI audio, okay? Now this one we're going to do some fun stuff with, but we'll get to it later. But essentially we've got the basic nodes that we need. So these can each play audio sources through the system based on the things that we configure them. It's nice to have them separate because we don't want playing a UI to cut out playing a music, right? We want the music to continue to play in the background. We're going to use 2 music things so that we can create a crossfade effect. There are ways now in here, and I'm not going to cover them today. There are ways that you can use things. They've got some advanced audio stream types like synchronized, interactive, and playlist that can do this for you to some degree. They're a little bit complicated. I don't want to say they're complicated. They're actually fairly straightforward and really powerful, but we're going to learn a lot more doing this than we would from trying to set one of these up. We're going to learn a lot more about how the audio systems work. And then you'll find that what we have here is pretty sufficient for most games. But, if you've got a game where you want cool things to happen, like maybe you want your music to be reactive to the game, and so you've got like a drum level that plays when you're moving and it stops when you're not moving, which is something that's been done in some Zelda games in the past, then you do want to make your music track something like this audio stream synchronized. And then you need an audio file that has the drum track separate from the rest of the music, right? And so this audio stream synchronized allows you to play back multiple streams and have them be synchronized. Okay, so that's what these are for. But I don't have audio sources. I don't have music tracks that are set up to utilize something like that. So it's just not something I'm going to cover today. It will be a fun thing to do in a different video, or you can find other sources out there to learn about it if you need it now. But there's my rambly explanation of why we're doing these. Now, one other thing we need to set up though before we're ready to begin doing too much, and it's important to finish configuring these nodes, is we need to look at our audio bus layout system. Okay, so what is this? What is this audio section down here? You can see that it's just got one thing. Up top it says default bus layout. We've got a master bus, which has some knobs and some letters. Those are letters, right? Not numbers, I think. And we've got effects that we can add. And this is, some of you are probably familiar with what's going on here. Some of you may not be. But essentially, you can think of these buses as different things that can receive audio that eventually pass them out through the speakers. And in fact, on master, you can see that the output is speakers. Okay, so any audio that's played through the master bus gets played through the speakers. And of course, by default, you can see that the master bus, it's our only bus, but that one is what's configured on all of our audio stream players. Now, when we've got a complex setup, though, like our game, we've got music, we've got user interface, and we're going to have general game sound effects. And, let's just run the project and show you our pause screen. Here, even in here, we've accounted for 3 different channels for playing back audio. What that means is each of these items, if they're going to be able to have unique or separate volume levels, then what we want is we want to play them back through a different audio bus channel, because otherwise we're going to have to set volume levels on audio players, and that's a lot more cumbersome, and it's kind of limiting, and honestly just not worth the effort, right? It's better to just add a bus. So we're going to add some buses in here. We've got at least the 3. In fact, I'm going to add 4 additional buses, okay? Because one thing that we didn't mention that is in here is we mentioned, and I'm going to name this first bus after it. I'm going to call it the effect pass. So this effect pass bus is where we're going to add things like our reverb effect, okay? And then we're going to have a bus for our music playback. We'll have one for regular game sound effects. I like to call it SFX. And then we'll have one for UI. Okay, so then what we can do is now if we come in here to our UI, we can change the bus to be the UI. You see how these buses now are reflected in our dropdown. Okay, so what does that mean? UI is going to be played back through this audio bus, and you can see that this is routed to the master bus. Okay, so any sound that comes in here, it will be adjusted by any settings you have on this bus layer. So, if we need to set the UI audio separately, we can just tune down the dB. And now anything that plays back through here is going to get reduced before it comes to our master channel and out the speakers, right? I think that's pretty straightforward and makes sense. And I'm going to go ahead and, how do I reset that? I feel like there's a right click or a double click or something. Maybe up here. Oh, there it is, reset volume. Okay. Right, so we've got a bus for that. Now, when we look at our sound effects and our music, we've got the same thing. But the reason I've put this effect pass here separate from these is because I don't want things like reverb to affect the UI, but I do want them to affect the music or the sound effects, okay? So what I'll do is I'm going to come to each of these, and I'm going to route them into my effect pass. You see how we can route buses into each other if they're up the chain? Okay, so we can do something like that. And in fact, you may even decide that you could have made this UI bus up here, but it doesn't matter too much. Okay, so now these are both routed through the effect pass. So what happens is if we're playing back music and sound effects, not only can they each have their own volume, but we can add an effect. We're not going to use the volume on the effect pass, right? We're going to use it strictly to add effects. So in the case of today's video, our effects pass is going to have a reverb effect applied to it, okay, that we could turn on and off or configure. So then our music and our sound effects will get that echoey reverb, but our UI won't. And of course, the effect pass is playing in through the master. So you can kind of see how this works, and you can create really complicated bus layouts if you want to or need to, so that you can do different things. But you can see how we're utilizing this to streamline and coordinate, and I'm going to reset the volumes on these, streamline and coordinate the audio playback in our game, right? Ultimately, everything comes out the master, but before it gets there, we have an option to make it do something different. And so let me go ahead and select these 2 music nodes, and let me set the bus on these to be the music bus playback. And now these are configured. In fact, we're not going to touch these music nodes anymore. They're fully configured. We just need them to play back through the music bus channel, and we're good. Now the UI, we will do more. Like I mentioned, we're going to use a special stream type on this one. In fact, let me go ahead and just add it. We're going to have to configure it later, but we want this audio stream polyphonic, okay? And I'll talk about what that is when we get to that point in the video. But there we go. I hope this is a good explanation of kind of what this bus layout is all about. Some things that you can do here, you can save these bus layouts. So if you have different layouts for different scenes in your game, then you can create multiple and you can save them and you can load them. And eventually in your audio, in this global audio script that we'll have, you could, load and swap out the different audio bus layouts if you need to. But that's more advanced, and I can't even think of a circumstance where you really need that. But I know some of you are going to come up with some cool creative solutions for it, and so you might need it. Okay, we're kind of doing a lot of setup and explanation here. We're going to do just a little bit more. I want to select these, and I do want to make it so I can access them as unique name. It's not going to make a huge difference. I just like to do that. And then I want to come in here to my project settings, because this audio scene needs to be a global scene, I'm going to come to globals, auto load, and let's find that scene here. Go ahead and select it and say open. And you'll see it's going to give it a node name of audio. And I think that's perfect for me. Go ahead and add that. Okay, there we go. So now we've got an audio global scene that will load, and we can attach a script to this. And that means that all of the functions and properties and all the methods and properties within this script are going to be accessible at a global level using that audio name. So let's see, what was I doing? Attaching a script. Here we go. And yeah, just save it right there in that folder. Okay, so now we've got some stuff going on here. We don't want to give this a class name because, as you recall, we cannot give a class name to a global. It will hide its name assignment in that global thing. So I'm just going to give it a comment. That way I can remember what it is if I'm looking at it. Okay, maybe what we should do to begin is kind of configure all of the imports, exports, etc. that we had to add to this scene or script. I'm going to use a few things. Like we're going to have reverb later. So I'm going to set up a reverb type enumerator. And this is just to make it easier because I want to just, when we get to reverb, I want to make it so that we just have to select from a couple different options. And you can expand upon this, of course, in your own game, but this is going to show you how this could work. So we're going to have no reverb, a small room, medium, and a large, okay? And I'm not going to get into trying to get too advanced on the reverb settings. We're just going to make these generic 4 settings. All right, so we're going to use an enum for that, so it's easy to set. And then we're going to need some export variables. I want these export variables to contain all of the UI audio, so it's easy to swap it out if you need to. So I'm going to go UI underscore, we'll call this one focus audio. And these are all going to be audio streams, right? So just like that. I'm going to go ahead and copy and paste this one. And there's going to be 5 audio UI audio types total. So we've got, let's see, is that 5? Yeah. UI focus, UI select. So this is like when a button or control is focused, when one is selected or clicked on maybe. We're going to have a cancel audio. We'll have a success, and we'll have an error. Now you may need others, but this is a pretty good place to start with audio. And that's all, of course, related to the UI. We are going to need some variables for our music playback. And so one thing we're going to do with our music, we've got the 2 music tracks, so we need to keep track of which one's maybe currently the active track, right? We're going to use some tweens to fade these, so we're going to need a tween variable that we can reference. And actually, we're going to need a special audio player reference that we're going to use for our UI audio. So let's set up some variables for these things. So first variable is going to be our current track. Now this is an integer, so I'm going to just set it equal to 0. It's going to be 0 or 1. Right? So that it relates to music 1 or music 2. We're going to have our music tween, or actually I say tween, but we're going to have multiple tweens happening. So I'm going to make it plural. And this is going to be a collection or an array of tweens. So just like that. And then I mentioned we want some access to a UI audio player. And this is going to seem a little bit strange right now, but you'll see when we get there. So this is an AudioStreamPlayer polyphonic. It's right down here. You see all these different playback types? This AudioStreamPlayer polyphonic corresponds to this guy here, right? This is an AudioStream polyphonic. AudioStreamPlayer polyphonic is like a child property of this, so... this is one reason why I don't like using these fancy stream types too much, especially in a video like this where I'm introducing you to concepts, because it gets complicated real quick if you're not careful. And I don't want it to be complicated. I want it to be easy. So these are our properties that we need. And then lastly, we just need to get reference to these 3 nodes here. So I'm going to just drag those in, press and hold Command and drop them, or Control. I actually said the Mac shortcut first. What is happening to me? What's happening? Anyways, so there we go. If I hide that output, now we can see all of the stuff that we've added here. Make sure your script is set up with all of those properties. And I think the next step should be maybe to assign the UI audios, because it's straightforward. We don't have to do too much there. I'm going to go ahead and just open my UI audio here. And let's see the focus. I'm going to use this bloop. Let's listen to it, shall we? Boom, 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 boom. Okay. There's that. So we've got a bloop audio, our select audio. That one's named the same, UI select. We've got, for cancel, I'm going to use this whoosh, UI whoosh audio. Let's see, for success, I've got a success audio. And then for error, there's an error audio, okay? So if we ever need to play any of these things back, like error could be trying to select something that the player can't do, right? So got a little musical thing. Same with select and success. They're just little, like I'm Zelda or something. So what I did for those is just create some basic little string of notes that we can play back to get those effects, okay? Should we listen to whoosh? We didn't listen to whoosh. Psh, cool. There, we listened to them all. I gotta listen to them all, man. Okay, so cool. We are configured with audio. We still can't play it back yet, though, because I'm slow as molasses over here trying to get this thing working. I'm going to go ahead and close some of these scripts. We're going to actually go back to some of those, but our global audio is set up and ready to program. Now I'm just going to go ahead, and if any of you want to use my little imitation of the success audio, you know, the one I made with my voice for your game, by all means do it. Send me a video about it. Okay, so the next step with this AudioStreamPlayer, I think, is let's start making something happen, right? Now, there's going to be other scripts that we're going to need to interface with this, or we're going to have to call this from other scripts. And so we're going to be adding other things during the course of this video. But we can start by working on this UI audio. I almost regret doing that because it's kind of the most boring and the least impactful. So bear with me. But this is important. What we're going to have to do here, let's go to create our ready function. The only thing we need to do in the ready function is actually set up our UI audio playback to work. Because what's unique about this one, and this is where we're going to get into this polyphonic thing a little bit, our audio stream players all have a polyphony value. Okay, but this max polyphony, if you look at the description, the maximum number of sounds this note can play at the same time. The thing is this will only work for a single audio stream. So what does that mean? If we're trying to play back UI whoosh and our max polyphony here is set to 3, then we could play 3 whoosh sounds. And as soon as we play the 4th, then that first one is going to get cut, right? But as soon as let's say we're playing 3 whoosh sounds and we play bloop, well, it's going to cancel all of the whoosh sounds, because what's happening is we're replacing the audio stream, and now it can play up to 3 versions of the bloop, but it no longer has reference to the whoosh. Does that make sense? So this polyphony only applies to the audio stream that's assigned, and as soon as we change the audio stream, well, now we're starting back from ground zero, okay? So the reason why we've assigned this polyphonic audio stream playback is because it has a unique properties. Now this has polyphony, but you'll notice it's different. This polyphony says max amount of simultaneous streams that can be played. Okay, so that's streams, whereas this is sounds, which is referring to singular stream of this one stream, okay? So what this means is we can have 32 streams playing different. That means we could play a whole bunch of these and mix different audios, and it'll play them all back, okay? And in fact, we could have used this method for our music and had only one player here, but you're also going to see that working with this polyphonic stream playback thing is a little complicated, not the most user-friendly, okay? And so really, I don't know. I'm going to show you how we can work with this, and we're going to for the UI, but I don't recommend it for other things. I think it's like the juice isn't worth the squeeze, as they say with this for many things. I think it's situational. But in order to use this polyphonic stream, this audio stream type here, we had to do a couple things. So what we're going to do is we're going to start by playing our UI audio, which is funny because we may not have anything to play, right? We don't have anything assigned. But what we're saying is, okay, start up this stream. And then what we're going to do is we're going to grab access to that playback. So remember how we defined this variable up here, this UI audio player, and you see how it's an audio stream playback polyphonic. When we hit play, whatever that playback is this. So we can, as soon as we play it, we can grab it. So UI audio player equals, and then you'll notice we can grab our UI, and there's a method to get the stream playback. Okay, that's what we want. Now this is going to return a stream playback of whatever type this is, and this, obviously we're using a polyphonic, so it's going to be that type of stream. Okay, so there we go. We've now started our UI, and when we run the project, nothing's going to happen because we're not actually playing any audio yet. But what we've done is we've managed to grab a reference to this node's stream playback so that we can manipulate it in code further. Okay, cool. So there we go. We've got a ready function complete. We're going to create several functions. And in fact, this particular script is going to be kind of lengthy, but it'll be clean. So we're going to have a function to play UI audio. And what this function is going to require is that we pass it an audio stream. So I'm just going to call that audio, and it's of type audio stream, right? All of our audio sound effects and things like that, these are streams. These are audio streams. So we can pass one of these in, and then we'll play it back, right? I'm going to just make this return void. And then what I'm going to do here is I'm going to say, if we have an active UI audio player, which we should because we grabbed it at the beginning, right? But this is just to be safe if for some reason this gets removed or something. But if we've got this, if we were able to get a stream playback, then we can go ahead and say UI audio player, and then we can say .play stream. Okay, so this allows us to add a stream to this polyphony of streams playing back. Okay, so we can just add that audio in right there, and voila. That in and of itself is actually pretty straightforward and pretty elegant, right? And how this will work is play stream. So what we do, you'll notice that there's some things in here like a pitch scale, volume, and an offset. So some of these settings here that you have on an audio, you can set per stream. We're not going to be doing that, but if you needed to, you could. Okay, we're just going to add ours and play them at regular audio from the beginning. You can even do things like set audio playback type and set a bus name and stuff like that. Okay, you can see that it says playback starts immediately. The return value is a unique integer ID that is associated with the playback stream, which can be used to control it. We're not going to be doing that because these are just going to play and end, but obviously that could be important if you're trying to keep track of the audio streams that you're playing. So they're each going to get an ID. And then once that stream is done, its ID becomes invalid unless it's looping, right? If it's looping, it's going to stay there. It also becomes invalid when it is stopped or stop stream for that particular stream is called. Now you can see lastly, it says this function returns invalid if the amount of streams currently playing equals the polyphony. If you need a higher amount of maximum polyphony, then raise this value. We're going to set ours to 32. We're probably not going to hit that. Okay. I just want to look at maybe this node. You can see that this is a, well, let's look at playback. Let's look at audio stream polyphonic. Lets the user play custom streams at any time from code simultaneously using a single player, right? That's what we're using it for. And really what this isn't describing super well is that essentially when we hit the maximum, then it just won't play anymore. And so what this functions a little bit differently, because if we had a regular stream player, right, how I described the max polyphony, once you hit the third, I think it cancels the first. But this is different. It just won't play the third if you can only do 2 or 3 or whatever, right? But it does free up these polyphony channels once an audio has finished playing, and then it'll just cycle back through and reuse those, okay? So having 32 different sound effects audios being able to be played at once is way more than we need. In fact, I'm going to drop mine to like 16. I think when I was testing this, I set it to 8 and never really ran into any issues either, so you can play around with that. The more you have, the more memory you're potentially using with this node. Okay, in a small game like ours, I'm not too concerned about that though. And in fact, I'm going to reset this max polyphony. We don't need that set. I think that was set for fun while I was talking about it, but really this is now the value that we're going to be working with. Okay, have I bored you enough yet? We can almost play UI audio. And I think for fun, let's do this. As soon as we start this, let's call play audio. Play UI audio, and let's pass in probably this success because it's a little bit more obvious. UI success audio. Okay. So if we run the project, we hopefully should hear it. Oh, yes. I hear the music. Okay. It's working. So that's good. In fact, if we wanted to, we could come in here and go to our script and play a couple of these at once. It's going to sound weird, but if we played the success and the error and like maybe the, I don't know, what's another one that we should play? The whoosh? I don't know. Well, what was that? Back or can't? What did I don't even remember. Cancel audio. Okay, I heard those. Did you hear those? I heard a and a boom. Okay, so you can see how we played 3 different audio streams simultaneously. Didn't have any issue with it, right? So that kind of demonstrates how this can work. So then if you're selecting a button and pressing it and then like hitting back all in quick succession, it's going to play those back, no problem, okay? And that's what we're using this for. So let's go ahead, and I want to create a couple ways that we can do this very easily, because most of our external nodes aren't going to have access to these, and I don't want to require them to pass this in. So I'm going to just create some functions real quick that we can use to play back each of these sound effects, okay? So that's going to be 5 functions that we'll create real quick. And I'm going to name them like this. I'm going to call it UI focus changed, or focus, what am I doing dot for? Underscore change. So what this is going to do is you're going to say, to call this from another script, you'll say audio.UI focus change, and it'll play this back, right? And so really all this really is just to play UI audio, and then we'll pass in that UI focus audio, just like that. So these functions are really simple. You obviously could call audio.play UI audio, but then it would be dot, the inside here would be like AI or audio.UI. Anyways, I think this is just a little bit cleaner. You don't have to do this, but I'm going to go ahead and create a couple of these. So we're going to have UI focus change. We're going to have UI, this one will be UI select. All right, we can play back that select audio. Muy bien. We'll have cancel. Okay. We want, what have we done? We haven't done success. Okay, and one more should be the error, and then I think we're done, right? Okay, 1, 2, 3, 4, 5. I think we got them all. Looking good. So now we can just call these, and it'll queue this up. Just an easy way for us to do it, though, without having to try and remember all this other stuff. So it's only a tiny bit simpler, but I'm going to make our life easy. In fact, I'm going to go ahead and just wrap these maybe in a region so that, you know, they're not going to make our code look too long if we collapse them. So we'll just call these UI functions. Okay, there we go. Now I'm going to go ahead and just collapse that region, but I should make a line return after it so that I can get there. Okay, but there we go. We've got all of our UI functions, and they're just going to call this play UI audio. We're going to add one more handy function for UI audio, but let's go ahead and demonstrate this real quick. So I'm going to open up, let's start actually on our title screen. Let's do that. So we've got our pause menu, and then we've got our title screen. So title screen, let's open this sucker up. We've got buttons in here, right? So one way that you can use audio playback, and I'm going to show you, do not replicate what I'm going to show you right now unless you want to do it the hard way. Okay, but I'm going to show you how this could work, and then I'm going to show you how we can streamline it. So when I look at my script on my title screen, which, man, look at that. Look at all that stuff. Generally, how this has to work, if we look at a button like new game button, there's no, and I kind of wish there was, there's no way. And you know what? If I'm really stupid and there is a way to just add audio sound effects for the default states of these, tell me. Yeah, but I don't think there is. What we would have to do is maybe on ready, we could come in here and say, okay, so for our new game button, twink, oops, wrong thing. Click. Oh, what am I doing? I've already got a reference to it. So let's say new game. Do I have it? Yeah, new game button dot. And then we could say like focus entered dot connect. And then I'm going to go ahead and just connect this audio dot. And then what did I call it? UI underscore. It's not recognizing it just yet, is it? Let me expand this. UI focus change. Okay. So this is the one I want to call. UI focus. Can I copy it? Give me right there. Yeah, I was going in the right direction. Okay. So we could do this and then we could say, okay, but when we press the button, it's going to be different. So there is a pressed signal. So we could say pressed. Yeah. Okay. .connect. And then here it's going to be, maybe we change these names, but what was it? UI select. Okay. UI select. Let's just try that. Run this scene. Uh-oh. Already running into an issue. Can't do this because returns value of, okay, it gives us stuff and we're not handling the value it returns. I'm already getting annoyed with this, right? Oh no, that error is because I put these parentheses on there. Okay, let's run this again. This should actually work. Okay, so you can hear when I select new game, we get the little boop. If I just hit enter twice on load. I meant to hit it once. Let's try that again. If we press enter on load, no sound, but if we press enter on new game, we should hear sound. Okay, so that's working. The catch is that's kind of a pain in the butt. I mean, this is a pain in the butt because we're going to have to do that for every button on the title screen and every screen where we use it. No way, Jose. I'm not doing that crap, right? So I'm going to show you a better solution. I mean, that's okay if you just got one or two buttons and you don't mind, but let's come in here to our audio script, and I'm going to come up maybe just right here before UI functions, and let's create a function. And what I would like is I would like any UI scene in my game to be able to just call this function, and this function is going to go through and grab all of the buttons and assign the appropriate sound effects. Voila. So it'll be one function call, get all the buttons in the entire scene. That sounds reasonable to me. I'm going to call this setup button audio. Now, in order to do this, we do need a node. We need a place to start, right? So I'm just going to say that we need a node. I don't care what kind of node, just a node. And then what we'll do is when we'll pass in a node, this script, and this is really simple, by the way. It's so simple that it's stupid that why don't we have this? But we'll just say for C in, and then we're going to go node dot. Normally we would use like get children, but I want to do this. I want to do find children. This is not the most efficient bit of code, but it's not terrible. And obviously if Godot provides it, it's worth using. And we're only going to do this like when the scene loads, and that's it. So what we're going to do is find children. You can see it gives us a pattern, which is a string, which is going to be like part of the name. And I'm going to use an asterisk because I want it to be a wild card. Let's go ahead and look at this definition. So it finds all descendants of this node, which is important because that means it gets children and grandchildren and great-grandchildren, okay? All descendants whose name matches the pattern. And if there's no matches found, it's an empty array, okay? Notice that it says this is done against their node names, not their paths. So this is funny because we're not providing a pattern here, but you'll see there's some other things that are going to make this. Let's see, it's case sensitive, an asterisk matches 0 or more characters, and question mark matches any single character, right? So typical wildcard, single character wildcard. Now this is where this is going to work for us. If type is not empty, meaning if we put something in type, only ancestors inheriting from that type are included. Muy bien, muy bien. If recursive is false, only the node's direct children are checked. You can see that recursive is true by default. So by default, it goes all the way through the tree. If you set this to false, then it only goes one level, just like get children. If owned is true, only descendants with a valid owner node are checked. I'm not sure I know 100% what that means, but we're not going to mess with that. Okay, so let's go back to audio. Sorry, that's not a great explanation, I know. Okay, so we're going to get nodes of any name, but we only want nodes of type button. And that's what's going to make this a little bit more efficient and obviously work how we want to. And then I am going to make sure, well, I guess we don't need to set true, right? That's true by default, isn't it? Didn't we just look at that? The next one, Yeah, recursive is true by default. Okay. So we're going to go through all of our, and we're going to go through this node and find all children of type button of any name. And then if we get a button, then we just connect to the signals. So we can go, let's see, c.pressed. I guess because this doesn't know that we're working on a button. But anyways, if c.press.connect, a button does have a we know that, right? Then we can just say, can we just call the UI select? UI select. I think that'll work. We may need to append it with the audio. We'll check real quick. We'll test it. And if it breaks, then we'll do that. And then we want to just connect to, we've got pressed and we want focused, right? Just like I did in that example. So we'll say focus entered. Yeah, that's the signal. .connect. And then here we'll say UI IO. What the heck, Mike? Focus change. Okay, we may need to come and prepend these with audio, but let's see if it works without it. I'm going to go to my title screen. Now, instead of doing this for every button, here's what we do. Somewhere in here, right here, in fact, we made a comment for this, didn't we? Add audio to buttons. So right here, one line of code is going to add audio to all the buttons in this scene. We're going to say audio, because that's our global class, dot setup. It's still not recognizing my methods yet, but setup, let's see, button underscore audio. Is that right? And we need to pass in a node, and we're just going to pass ourself in as the node. Okay, so that means that this title screen is going to just pass itself in. We could choose a child like this control. It's not going to make a huge difference here. And then our audio thing's just going to go, okay, sounds good. Let me find all your buttons and connect to them. Nice, right? So if this works, let's see if it works. Let's run our title screen. Hey, look at that. Hey, seemed to work. Now our pause menu doesn't have any sound yet. So, but we can just apply that same one-line script here as well to our pause menu, right? So let's go do that real quick. I need to find said pause menu and open it. Really, we only need to open the pause menu script. And then here in our ready function, hey, look at that. We knew we were going to do this, didn't we? Audio dot setup. Why is it not recognizing my, I might need to like reload the project or something. I don't know. In fact, let me try that real quick. Let me see if that fixes it. Okay, I reloaded the project. Go audio dot setup button audio. Oh, thank you. It worked. And I can pass in self here as well. And let's go ahead and run the game and just see if our pause menu has button audio now. No, it doesn't. Did I put that in the right place? Pause menu, audio, setup button audio on self. Huh, what happened? Why no worky? Oh, and I think I realized what's happening here. That didn't work with the pause menu because let's check one thing. Let's make sure we missed a configuration. Good thing we caught it. This drives me nuts sometimes. Okay, so this process mode, it's set to inherit. It's pausing. So I'm going to set this to always because obviously we want our audio to always work. Okay, now if I run it again, please work. Please work. There we go. Okay, so you can see it. Now it doesn't hook up to these things when I select them, but because they're not buttons. So we could add additional branches of logic if we want to set up certain types of audio with these as well. But we're not going to today. We will have some audio playback when these change volume later. So for now, I think this is sufficient. Our pause menu and title screen now have UI button audio. And we've made it so it's super reusable, right? I mean, you can, any node, you just need one line of code to make all of its buttons have appropriate audio. And it will be consistent throughout your game. So that's going to save you a ton of work and a ton of time because you can just come in here and adjust things as needed and you're good to go. And like I mentioned, if you decide that you need to add other types, like maybe you want sliders to happen, then you can do, you could either do another for loop. I think it might be more efficient to maybe check the types in here. I don't know. I'm not certain exactly how I'd want to do it. Maybe do another for loop and just check for sliders. And then, you'll connect to different signals and maybe you'll connect different bits of audio. Okay, but there we go. Pretty cool, pretty cool. Okay, UI audio, basically we're done. Okay, you can extend this and expand it as you see fit. The next thing we'll tackle is going to be music. Let's do our music playback. Okay, so music playback is, music is critical to a game. And if it's not music for you, if it's just ambient audio, then it's the same concept, right? And actually, the music is going to be more code, okay? It is a little bit of code to get through and to make it work and handle all the transitions. But let's start with the basic and let's just play some music. Okay, so when we play music, obviously this function, again, we need to pass in some sort of audio track that we can play. I'll stick with the generic audio name for that property. And we need a way to get our current music track and things like that. But really, just to start, let's just do the simple start, or the simple piece. And let's just assume we're going to just play some music, period. So all we need to do is, I'm going to start with our music one dot, we need to set the stream. So the stream is going to equal the audio that we passed in. And then we need to play it. So we say music one dot play. So if we were to come, say, to our title screen, and let's just add in our script here. Let's assume we wanted to trigger it here. We would say audio dot play music, and then we pass in some music. So let me just go to my music folder and grab the title, plop it in. Okay. Wrong thing. Let me hold Control and plop it in. There we go. Okay. Run the title screen. Oh man. Awesome. It's playing. It was loud. Reverb is on. Let me turn reverb off. Let's try that again without reverb for fun. Cool. Okay. You can see the difference, right? Reverb, no reverb. So that's pretty straightforward, but this is not quite how we want to do it. And this doesn't really account for things like when we change scenes. And in addition to that, I don't even want to have to come into every script and add that one line of code, because like with our levels, where are we going to do that? Right? We don't have a script on our, like, level one. There's not a script on here. Where do we add it? Do we add it to our level bounds? Do we, what do we do? So what I'm going to propose, and you can copy this or you can do something different, but the principle will align. We're going to create a music area or a music playback node that we can just drop into any level. And that means when we enter the scene or the level, it's going to start playing some music, right? Pretty straightforward. In addition to that, we're going to make it so that our audio system knows, like, okay, if the music is the same as what's currently playing, then just keep playing. But maybe if the music is different, then we'll transition. And we'll support playing no music. I think that's fine. You may choose to interpret no music as continue playing whatever's currently playing. But I'm going to actually play no music. So like in our save, are the screens in their level that are a save room, I'm going to play no music. Maybe it gets replaced with something tranquil and subtle, but for now it's going to be nothing. Okay, so there's a couple ways you can handle that, but we're going to build all of that into our play music functionality here. So even though that was great, deleting more code, we just have a play music function, and we're going to build this out as we introduce these scripts here. Okay, so let's create this. Here in our music folder, I want to add a new script. So create new script here. I'm going to call it music auto trigger. Now this is going to be fun. You could expand on this concept and make it so that you have like area transitions that when you enter them, they do a similar functionality. This is just going to be fairly generic. Like as soon as this script loads, it's going to send a signal, I'm going to say, but it's going to call the audio script and say, hey, play this. I want to give this an icon. We've got an icon for it. So let's use it. Now the icon here in general, music trigger, plop that guy in there, and we'll give it a class name as well. This will be a music auto trigger. Okay. And it can just extend node because it's really not going to do anything positional or anything like that. So all we really need to do is I'm going to export two variables on here. We're going to have one for the audio that we want to play, or the music track. You could even call it track. This is an audio stream. And then I'm also going to export a variable that we'll use later for our reverb. Okay, so I'm just call this reverb. I'm going to go audio dot reverb type, and by default we'll set it to none. Okay, all this script is going to do is it'll have a ready function and 2 lines of code. We're going to call audio.play music and pass in the track. And then eventually, and let's go ahead and set this up now so we can just write the script and call it good. We want to have a set reverb function that will set to this reverb value. Okay. This means that you can keep the same background music playing, but change the reverb independently, right? These two things are separate from each other. So let's go ahead and go to audio and let's create this set reverb function just so that that doesn't give us an error. So I'll probably do it right here under play music for now. And we'll get here. I'm going to change this to type. And this will, of course, be a reverb type. Okay, there we go. So we'll do this function later. Same with play music. We're going to set these up a little bit. We'll come back to this play music. So this is all this function is going to do. So essentially what we can do here is like on our title screen, we can just do, so you'll notice we define this as a unique class and it's a script. It's not a scene. So we can just do a Control A. And then if we type for, look for music auto trigger, it doesn't have the icon because we need to reload the project. So let me go ahead and create one. And you can see we have a track. So I could just load and I want a title screen, reverb. I can change it. I'm going to leave it on none. So now by adding this, if I run the title screen, then we'll hear music. No, we won't because I removed the code, didn't I? Let's go back into our audio player. Let me add that kind of that basic code back in. And then run the title screen just so we can demonstrate this. Okay, cool. And to take it one step further, let's go to scene 1 and I'm going to add an audio trigger here and just give it the forest music. Okay, so now if I run my title screen and start a new game. Cool, it changed the music. Now, if you're good with that hard audio cutoff that we've got there, then that's all you really need to do, right? We're done from that point. But obviously we want to add in some transitions and stuff. So that's what we're going to work on next. But of course you can see the benefit of having this single node that we just add, simple little items to configure, and you're good to go. Before we go to the next step though, I'm going to go ahead and restart my project so that these icons show up. Okay, I've restarted my project. You can see my music auto trigger node is there. Looks nice, easy to identify. But we need to start working out this script. So first thing is I am going to clear this or something. I just want to talk about what this function needs to do in order to work. So first step is we need to kind of get or determine the current music player. Okay. And then once we've determined the current music player, then we need to determine which the next one will be. So if we're playing on music 1, then the next one is music 2. If we're on music 2, the next will be music 1. So we can do that. Then we can obviously set the audio on the next music player. We can leave the current one alone. All right, the current one's going to fade out, so we'll leave it. And then after this, we can handle the audio fades. And then lastly, once this is all done, because we have to do this last, we can then store what the current music track is. Okay? So that's what this function is going to do. We're going to build a couple helper functions in here. So for example, our audio fades is going to be redundant because we're going to have to do fades to both tracks. So we're going to create a function for that. And we will also create one other additional function to help us get or grab access to the different music player depending on, what our current track is, okay? But that's the outline for this play music function. All right, so let's start with this first bit here where we get and determine the current music player, okay? Now this function that we create for this is going to work for both getting the current as well as the next music player as we need to. So we'll go ahead and just create this right here, a little function. We'll call it get music player. And actually that does not return void, does it? It needs to actually return the music player, which is an audio stream player. Okay. And obviously that's going to need to return a value. So in order to be able to get one, we need to maybe also provide the index of the music player we're trying to get, which is an integer. So this is pretty straightforward. We could do this up in the code. We don't need a separate function for this, but it helps keep it cleaner. We'll say if I is equal to 0, then we know it's the first music player. Else we can return music 2. Okay, so pretty straightforward little function, but that's just going to make our code up here a tiny bit cleaner. So let's go ahead and remove this comment and replace it with some actual code. So we'll define this as a variable in the scope of this function. So the variable we call our current player, not a plus, Mike, which is of type AudioStreamPlayer, right? So this will equal, and what we're going to do is we're going to say get music player, right? Is that the function that we wrote? Yeah, get music player. And then here for the index, we're going to use this current track. So we're going to have to change this, right? But right now the current track is 0, which is good for the default. So we'll pass that in as the argument there, and that'll give us music player 1. I had mentioned previously that if the audio stream that we pass in is the same as the one that's currently playing, meaning it's the same music track, then we just want to return. We don't want to start the track over, right? So we can do that check here because now that we've got the current player, we'll know what it's playing. So we can say if current player dot stream is equal to our audio file, then we'll return. Okay, don't do anything. So there we go. First little step is complete. Now next, let's look at this determine next music player. Okay, we need to start by defining a variable to help us know what the next index is. So right now our current track is 0. Okay, and so when I say the next index, I guess I'm referring to that. So we could call this next index or maybe next track. I'm going to call it next track. I think that's okay. So this is an integer. I hope that's not a confusing name for you guys. But this, how we're going to do this is we're going to use the wrap I function. Okay, so this will allow us to change a value and have it wrap from between the minimum and maximum values that we provide it, right? Okay. So we're going to go back here. Wrap I, the value we're going to wrap is, and I know we're not wrapping like that. Current track, right? The same value that we've used here, plus 1. So just increase it by 1. And of course, we need to have a minimum, which is 0, and a maximum, which is 2. And let's go back to this documentation so you understand this. The minimum is inclusive, meaning it can be the minimum value. The maximum is exclusive, which means it cannot be the maximum. And in this example, you can see this loops between 5 and 9. So it can be 5, but if it gets to 10, then it's going to set it back to 5. That's kind of how that wrap works. So it can be 0, but as soon as it hits 2, we go back to 0, which means there's only 2 potential options right now, 0 and 1. This could, of course, be extended to support more music tracks if needed. So now that we have a next track value, we can get the next player. So the next music player, newt. Well, the newt player. Oh, she turned me into a newt. Next player, AudioStreamPlayer. Okay. Just like we did up here for the current player, it's basically the same, except instead of using next track, we're going to, or current track, we're going to use next track. There we go. Okay, cool. One more step complete. Of course, we kind of have to finish this whole function before it's really going to do anything, but we're making good progress. Next is set audio on the next music player. So in this situation, what's happening is like audio player, music 1 is playing music, and now we need to set the music on player 2, okay, and begin playing that so that we can do that fade, the crossfade between the 2 tracks. So we can set the next player dot stream equal to the audio, and we want to call play, next player dot play. Okay, so that's going to set that track to the audio stream and play it. We're going to do our audio fades. We're going to use tweens for that, and then let's do this last line of code next, store/set the current music track. So what this means is once we're all done, we now want this next track value to be the current track, or current track should equal next track, right? Because we changed it. It was 0. and now we're swapping to 1. Or if it was 1, then it was 1, and now we're swapping to 0. But we don't want to do this until after we do these tweens, because the tweens are going to reference the tracks according to those integers, right? So we need to keep that intact until we finish all that code. So current track equals next track. Okay, there we go. So that leaves us with just one thing, and that's handling the fades. At this point, though, we should have the ability to play the music, but let's go ahead and test just to make sure it's working. So here in scene 1, I've got forest music, and let's go ahead and set up a couple other scenes with some auto trigger nodes. So I'm going to just copy that. I'm going to show this in my file system. Okay, I've got a lot of scenes here. Scene 2, maybe this one also has that same forest track. Our save scene, as I mentioned, what I'm going to do is I'm going to set it to no audio track, if for no other reason than to demonstrate that. And then let's see, let's open scene 3. This is a dungeon style scene. So let's use, there we go, paste that in there. I want to change this from the forest track. Let's go to quick load. I want to use dungeon. Okay. And now I'm going to copy this, and I'm just going to go through these remaining little levels. They're all dungeon as well, and swap that music out. Okay. Now it's not going to matter a whole lot for these. These are all connected, so they're going to be playing the same audio track. Not a big deal. But let's go ahead and start on this particular scene, because this has a transition to a dungeon level. Okay, so there's one music track playing, and let's go down here. Oh, what is happening? So you can see that our code isn't complete, but we had both of them playing at once, so you can see how that's going to work, right? So next we'll do this audio fade. Okay, handle audio fades. Technically, there's a couple things that we need to do here. One is I might need to demonstrate this, but we're going to need to kill any existing tweens, and I'll show you why. And then we need to handle audio fades is technically we're going to create new tweens, okay? And let's start by creating a function that we can do this, because we need to tween both the current and the next track. So we need to fade the current one out and the next one in. Okay, and we'll do that with the simple tween. And then I'll show you this kill tweens thing. Maybe after we demonstrate it. I think I can demonstrate buggy behavior, and that'll help sell the reason why. So let's come down here after get music player. Let's create a function for, let's actually create two functions. We're going to do one for fading out and one for fading in. So we'll say func fade track out. Okay, and then we'll have a fade track in. We'll create, well, let's go ahead and just create it real quick. And I should have done this before I did that, but both of these functions require an AudioStreamPlayer. Okay, so we're making these generic, right? So that we can pass in either of our two music stream players. Okay, there we go. So fading, actually, you know what? Let's start with fade in because it's a little bit easier. For both of these, we're going to create a new tween. So we're going to say variable tween, create tween. Okay, so we'll get a new tween. Then what we're going to do with this tween is we're going to take our music tweens array and append it. This music tweens array and adding these to that array are solely so that we have reference to them here when we need to kill the tweens. All right. Okay, then what we're going to tween is we're going to tween, let me pull up my audio scene and look at one of these. We have a volume and it's in decibels, which is kind of a weird value system to work with. It doesn't make a whole lot of sense. It's not like 0 to 100 or anything like you would expect for a volume knob if you're using a more consumer facing kind of appliance, right? If you've got a high-end thing, then you might use decibels on those. But because decibels can be kind of weird to work with, like 0 is normal, full volume or something, what we can do is we can utilize a linear version of this. So Godot knows that this is hard to work with in code sometimes. And so there's a linear volume attached to these that we can utilize. It'll adjust the decibel volume, it converts it, but it allows us to work in a kind of 0 to 1 scale. So what we're going to do then is we're going to take whichever audio stream player gets passed in, and we're going to, for the fade track in, we're going to fade the volume from 0, or in the case of decibels, it's maybe -80, right? To 0. And so here's how this looks. We say tween.tween property. Okay, so with this tween property, we're going to tween the player. We're going to tween the volume underscore linear property. The final value. So if we're fading the track in, then the final value on the linear scale is 1. That's maximum volume. Okay, 0 to 1. And then we're going to fade it in at 1 second. Okay, now I'm going to copy these because these 3 lines are very similar. They're the same except for the tween is going to be different. So for fading out, we're going to fade to 0. And I'm going to fade this one more slowly. You can choose to do how you like. I'm going to maybe make it 1.5 seconds. So it'll be fading out a little bit even after the new track gets to full volume. This one will be kind of just barely fading out for 0.5 seconds longer. But we also want to stop playback of this music once the tween is complete. So here's what we'll do. We'll go tween.callback. Oh, what is it? It's tween callback. Okay. Callable is a function. And we're going to call a function on the player itself. So it'll be player.stop. Okay, so that means it'll stop playing, right? These 2 functions are ready to use. So we can come up here and where we create our new tweens, we can just call them. So what we need to do is obviously we need to fade out the current track or current player. So we'll say fade track out. And we'll use our current player. And then we will fade track in and use the next player. Okay. The more I write this and type this out, the less I like player, but it's an audio player. I don't know. Change it if you want. Okay. So that's going to be enough to do the fade. We are not going to kill the tweens right now. Let's go ahead and test this first and get a sense for if this is working. It should be. So I'm going to go to scene 2, just run this scene. Okay. There we go. Faded the first track out and the second one in. There we go. Faded back to the other track again here. The music volume for me is actually quite loud. I think it's probably going to sound a little bit okay to you guys. We'll adjust that in a minute. But I wanted to just come in here. You see how we faded out to no music because we went to the save screen. And I'll go back out to this dungeon area. Get a new audio track. Okay. Now, there's a little bit of a bug there. You can kind of hear it. Sometimes it's just going to stop. See, that fade just stops. Because what's happening is we've got these tweens. These tweens are playing back. And because they take 1 second and 1.5 seconds, it means that we could leave a level and come back and that original tween is still happening even though maybe we don't want it to anymore. So that's what the purpose of this kill tweens section is for. We want to stop any existing tweens. And so if one was fading out and it needs to start fading back in, what can happen is eventually that callback function to stop playback will hit. And then we can end up in a level without music because of that. In fact, maybe I can demo that. Let me see if I can demo that between these 2 real quick. Yeah, see, no music because the fade in happened, but then the stop callback happened a split second after it because that's partly because of the timing I built into it. I think if you had the fade duration the same, it maybe actually still could be buggy. In any case, we're going to kill the tweens because it's just going to work better. So here's how we'll do this. We'll go for T in, and we've got music tweens, right? We did add those here. There it is, music tweens, append. Okay. So for T in music tweens, we're going to just kill it. T.kill. And if we look at this, it aborts all tweening operations and invalidates the tween, basically becomes null. Okay. And then because we're killing these tweens and they're like now null values, what we're going to do after that is we're going to take our music tweens array and just call the clear function. Okay. So that means it's now a new clean empty array because we've already killed these and yeah, clear them out. Okay. We'll do that before we do this. Now, if I run this same scenario where I hop back and forth between these levels, it's not going to ever terminate prematurely and just stop music altogether, right? And in fact, it's even better because it's a little bit hard to notice there, but these tweens, when we look at these, they don't specify a starting value for the property that we're tweening. So if the volume had faded out halfway and then you triggered a tween to have it fade back in on that same player, then it's just going to start at half volume and fade in. Okay, there we go. We've now got a handy dandy little music track system. Fades our music playback, works with these nice music auto trigger nodes that we can drop into our scenes. And I think we're good to go there. Okay, pretty awesome. And I would say that this audio system that we've built is pretty robust. There is one additional feature that I want to add. So we mentioned the ability to play spatial sounds using an audio player 2D. And this functionality is going to be straightforward, somewhat optional, although we're going to use it and implement some sound effects in our game right now. So let's see, I'm not sure where I want to do this. Before, after music, somewhere. Right here before play UI audio maybe. And it would be nice to come through and maybe make some tags and comments in this code to organize it. But I'm going to go ahead and just call this play spatial sound. Let's talk about this function. So this function, we need to be able to tell it a sound we want to play, but because it's spatial, we also want to tell it a location in the game world that we want to play it at, right? So let's go ahead and provide some arguments so we can do that. We need our audio stream, so that's audio is what we'll call it. And then we need a position. I'm just going to call that POS vector 2, right? Okay, so those are the two values we need to pass so that this function can do its job. So what we'll do is we will create a new audio player. And this is going to be an AudioStreamPlayer 2D. There we go. Because remember, our audio scene doesn't have anything for 2D spatial sound. And rather than try and set something up that we can do different streams, obviously if we're playing multiple streams but then moving the audio, then the position of the other ones might not line up. It gets complicated. This is just an easy way to do it. What we're going to do is we're going to create this AudioStreamPlayer 2D and play it. And then we're going to queue it up so that as soon as it's finished playing the sound effect we've assigned it, that it will just free itself from memory. So the AudioStreamPlayer is going to equal an AudioStreamPlayer 2D .new. That's what we want for these nodes. Okay, so we create a new one. Then we can add this as a child, so we can just add it to our current scene here. Now we need to set the bus channel because, you know, these players here, we're setting the bus in the inspector, but we don't have that option there. So we're going to say ap.bus equals, and then we can just provide, this is a string name, so sound effects is our bus name, right? Let's go ahead and open that up again so we can see, yeah, right here, sound effects. Cool. Now we need to set the position. So we're going to use our global position for this, and we're going to make sure we pass a global position in, but this will just be equal to the position passed into the function. We can set the stream to the audio that we've passed in. And then I mentioned we want to terminate or queue free this node when it's complete. So we're going to say ap.finished. Okay, this is a signal on our AudioStreamPlayer 2D when it's done playing its audio. So we'll connect to that. And we can just connect queue free, just like so, okay? And then lastly, and actually not queue free, we got to be careful there. We don't want to queue free this. We want to queue free the AP. Queue free without AP would free the audio scene. We don't want to do that. Okay, so we're going to have this object call its queue free. And then the only thing we haven't done yet is actually play the audio. We'll start the playback once we've set it all up. So this is pretty straightforward. Now we can call this anytime we want. There are going to be a lot of ways you could utilize this play spatial sound, and if you don't want to use it, you don't have to. But what's nice about this is it's not going to be limited by polyphony issues because you're going to create a new one. You might have to be careful if you've got something where you're spawning really high numbers of objects and they're playing sounds through this. That could become an issue because if you're, I don't know what the performance implications would be for instantiating like 100 or 1,000 of these each frame. If that ever happens, like if you're making a bullet hell game or something. So just be careful how you use it. But for most use cases, this is perfectly fine. Godot is actually extremely efficient at creating nodes and freeing them and handles memory really well. So it's not a major concern for most games. Let's go ahead and implement this on, I'm thinking, let's see, what scene is it that has it? 4, 5, 6, 6. So this door and switch that we made, each of these in that last video, if you recall, we had a spot where we wanted to play back audio. So here's an audio playback, and we have an audio stream, this door crash audio. So let's use our audio system for this. We can just say audio dot, and then play spatial sound. And then what we want to do is pass in the audio, and we can just use our global position. Okay. Likewise, we could copy this same code here, our switch. If we look at our switches, I'm just going to open the script for it. It has an audio playback as well. It's got a different audio, right? It's this door switch audio. And just play this back at the global position. So now if we run this scene, we're going to have some music playing. Cool, we've got sound effects. And I don't know if you noticed it, but that should have been kind of in your left ear. Let's go ahead and do something. Now, this is a good opportunity to explain something or demonstrate some things in the audio bus setup. So not only do we have the ability to adjust volumes on each of these, but we can come in here and we can mute one of these buses if we want. So if we mute the music bus and run a scene, then we're not going to hear the music playback anymore. Okay, and we'll still hear this audio. Now that switch and everything was close enough to the center that it was still somewhat centered, but for me it was in my left ear a little bit more than my right. Alternatively, with the audio here, you can, instead of mute, maybe you have a whole lot of audio players, you can also solo. And what solo will do is only play that one, which effectively mutes any others. See if this works. Yeah, I wondered if that would happen. I just had that thought. Technically, when you solo, so the way I've set this up, solo doesn't work very, very well, does it? Because if it mutes the master bus, then and this one feeds into it, then or the effect pass, it just doesn't work. So maybe you just want to mute them. And then B is bypass, so you just kind of skip over it. It's kind of would be useful maybe if you want to bypass the effect pass. I don't really ever work with this one, so I'm not quite sure how it works, but there we go. So yeah, if you just want to come in here and mute your music to test your sound effects, you can. That might also be helpful for testing UI sound effects because they're generally a little bit quieter than some of the other stuff. Pretty cool, pretty simple way to play back some 2D audio, right? And so you could go through at this point and hook up audio on a whole bunch of things. In fact, let's go to our save point and let's see, where do I have that for me? That's going to be under general save point. There it is. If I look at this script, I think we may have made a comment. Yeah, we sure did. On player interacted, play some audio. Now in this case, I'm going to do a UI audio. So I'm going to say audio.ui, and then I want the success one, I think, just like that. So then if we run our game, come over here, and when we save it, we should get a sound effect. Okay. Now, obviously, you might want a different sound effect. I'm just working with the limited supply of audio that we've got right now, but it's pretty simple at this point to go through and start hooking things up. One line of code, for the most part, is all you're going to need to be able to play back any kind of audio. All right. Even in the situation where you are like our door and whatnot, you don't even need to have a reference to this door crash audio to be able to use it. You could replace that by just dragging and dropping in and preloading or loading that audio on the fly. And depending on your use case, that might be fine and totally appropriate. Okay, but I do think it is cleaner to have it this way, or maybe this is an export variable because maybe you have different doors that you want to assign different audio to. You know, that's up to you how you handle that, but pretty straightforward, pretty easy peasy, right? Okay, 2 more features. So these are all awesome. These could all be their separate video, but I wanted to put it all together in one so that we could see really how these are all working together. So we've got reverb that we want to add. And then I want to go, the last thing after we add that reverb is I want to go into our pause menu, and we've got those options in here, right? In fact, I got to do some quick cleanup. I added a little extra color rectangle on my own. It needs to be part of this map or this pause screen. So I'm going to drag that in there and drag it up to the top. Okay. In this system menu, we've got these sliders. I also want to hook those up so that we can adjust the volume. And not only are we going to adjust the volume, but we're going to save it to a config file. So you could either save these settings per save file, per save game, or you can just save it for your whole project, meaning there's one set of settings for the whole game, and it doesn't matter which save file you're on, it's going to pull them. And so we're going to do the latter. We're going to just have a config file that saves with the values that the user has input for each of these. And then when you start the game up again, it'll remember your volume settings, okay? So let's go ahead and do the reverb though first. And in order to look at that, we're going to look at, let's go ahead to one of these scenes. This is a good example scene. So scene 6 here, it's a dungeon area. We've got some sound effects to work with. And let's just go ahead and set a reverb here. Let's say this is a medium-sized level. Okay, I'm going to go ahead and save that. Right now, that's not doing anything. In fact, we've got a debugger warning because we have a function where the set reverb and the type is not being used. And they recommend we give it an underscore if we're not going to use it. But we're going to use it. So let's go in here. Let's open our audio script. And if you recall, we're already calling this set reverb function, right? We're calling it from the music auto trigger and we're passing in the type. So we just need to determine what to do based on that type. So in here, we need to get access to our audio bus that has the reverb effect on it, and then also get that reverb effect instance so that we can manipulate the settings on it. And then after that, just depending on which preset we've picked, right? We've got the 4 types, none, small, medium, and large. Depending on which one is selected, we'll just set our reverb to different values, okay? I'm going to start by grabbing that reverb effect. So here's how we'll do this. We'll say VAR, it's going to be reverb underscore FX, maybe. These effects on this audio bus here, like this reverb, they are of type audio effect, and then each effect has its own subtype. So this is an audio, you see here, audio effect amplify, blah, 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 blah. Because we want to be able to access the items, you can see all of these lots. On the reverb, we want it to be an audio effect reverb. And so what we do here, this is kind of tightly coupled version of the code, but it'll work fine. We're going to grab our audio server. Now the audio server references basically everything that handles the audio. So our bus is a part of that. So we say audio server, and then we can use some functions here. There's a get bus effect. That's what we want. There's lots of fun things that you can work with in here, and certainly a lot to explore. Now, how this works is we need to provide a bus index. So these are by index. So master is 0, effect pass is 1, and then we need an effect index. So you can have multiple effects on here, right? So if we had like a whole bunch, in fact, a limiter might be smart to put on here, or maybe we put a limiter on the master. What a limiter does is if your decibel range gets higher than the limiter value, the ceiling, then it just clamps it, which is good for preventing things like audio defects when the volume gets loud. So, when you have someone yelling into a mic and it just sounds terrible, that's because they're not limiting. They need to put a limiter on their volume. I'm going to go ahead and remove those, but these will be 0, 1, and 2, right? If we were to get those effects by index. Okay, remove, delete. We're just going to work with our reverb right now. So we're looking at index 1 and index 0, right? And it'll return us whatever that effect is, and it's a reverb effect. So if you set yours up differently and you've got other effects, just make sure that you get those indexes determined properly. So 1, 0. That's going to get us our reverb effect. And now that we have access to it, we can manipulate it. We can do a quick check, though. We can just say, like, if not reverb effects, then we can return. Okay? Just to prevent errors. There might be other things that you might need to check for if you've got a different setup. You'll notice there's this checkbox to enable or disable. And what we're going to do is we can leave it enabled. Every time we change the reverb, the first thing we're going to do is we're going to enable this effect channel. We just have to grab our audio server again. And then there's a function to enable or disable a bus effect. So we say set bus effect enabled. Same thing, bus index, effect index, and then the enabled value. So 1, 0, and then we're set it to true. It's enabled. We're going to need this code in a second, so I'm going to copy that. Then we're going to do a match statement, meaning we're going to take this type, and depending on the value, we'll do a different line of code. So if it's reverb type none, reverb type dot none, right? Then we'll just set this back to false or set it to false. Okay, so if they select none, we disable it. If it's reverb type small, then what we're going to be manipulating, if we select this reverb, there's a lot of values on here. In fact, it would probably behoove you to improve how you handle this reverb if this is something that you really want to get into for your game. We're only going to be manipulating the room size, but damping and spread, high pass, dry and wet, these all have an effect on how it sounds. And there's also this pre-delay, okay? So some of these things you may want to tweak with, and depending on your knowledge with audio, that's going to be easier or harder. And I love to tinker with audio, and I understand most of these to some degree, but I'm not an expert on how to really configure these. So I would just recommend maybe doing some Google searches, and if you're trying to hit a target environment, I'm sure you can find some values out there that are going to work for that environment. And so maybe when you have your reverb types, maybe they're more than just small, medium, large. Maybe it's like cavernous, cathedral, things like that. And then it has more than just room size changes. Okay. So with all that said, though, here's what we're going to do. We're going to grab this. We're going to get our reverb effects. And then we'll set the room size. So we're going to say dot room size equals. And for a small room, we'll do something low like 0.2. And I'm going to go ahead and just copy both of these lines of code and paste them a couple times here. So we've got medium next. And for medium, let's set it to half. And then we'll do large. And yep, all caps. And we'll set this one to 0.8. I don't know if we need to go to 0.1. Okay, so because we have scene 6, we've got this music auto trigger set to medium reverb. We should hear reverb when we run the scene. Yeah, you hear that? It's going to affect our other sound effects as well. Pretty cool, right? Now, what I want to do, though, is I want to go to a couple, like let's go to scene 5 and let's pick large. And then maybe let's go to 4. What's scene 4? Wait, which scene 5? Oh, okay. Scene 5 is small. And then scene 4 can be large, right? This is a bigger room. I'm basing it off of the size of the room explicitly, but, or like the height. I don't know. Let's just see what this sounds like. Okay, so this is a medium-sized room here. Small room, less reverb, right? Large room, lot of reverb. And so you might want to go and tweak those values and adjust things to your liking. But you can see that we've got that dynamic reverb. Could be something really cool. Easy way to add some extra atmosphere to your game. And I want to do something real quick. I'm going to come over here. Can I mute my audio? Is that going to save? No. Let me just run it again. I just want to hear the sound effects without the reverb. Yeah, that worked pretty good. You can hear it. It sounds a little bit tinny and weird, but that's partly because of the bit crush nature of the audio that I'm using. So, you know, if you've got a higher bit rate audio, more realistic sounding audio, then it's going to sound pretty good with that reverb. And it's not that I dislike how it sounds with the low bit rate. It just might sound a little goofy. I don't think you'll hear that with your other audio, I guess is what I'm saying. So there we go. That's pretty easy to get that reverb effect, right? Now, I guess the last thing is let's give some volume slider functionality to this game, and then we'll be set. We'll have all of the core functionality that we need for our audio for the rest of our game project. This stuff will be set in stone, and we don't have to worry about it. This is why I wanted to build this before we start putting audio on everything, because you know, your system needs to be in place to inform decisions on how you implement audio on an individual node or feature basis, right? Now, I want to make a comment on something first. So as I'm testing this, and it's not going to sound as bad to you because I've got some audio ducking happening, but you probably have sensed this, though. My music is really loud, and I have my music set to a level that I think I like. And by that, I mean on a per audio track basis. Like when I listen to the music, it's good, but it's too loud when I'm playing the game. So really, you're going to want to duck this audio on the music channel by a certain amount. Some people are going to want to really blast it, though. And so there's a couple ways we can handle this. If we try and handle this audio volume on these, then that means we have to set our tweens to tween to, maybe they don't go all the way to 0. Maybe they go to 0.8 or something like that, right? Or we set the audio lower on the music channel. The only complication arises when we introduce the next feature where the user can configure and set the audio. So that means like, is 0 to 100 for the player really 0 to 80% on the audio bus? You know, what does that look like for you? And the same could be said for sound effects and UI. And so what I'm going to do with mine, and you can change this, and it'll just be a little bit of change in the code. I'm going to go ahead and reset the volume. I'm going to assume that 0 decibels is 100 volume for all of my settings. But then what we'll do as we build in our configuration, I'm going to build in a default. So I'm going to say my music volume is 80%, and then maybe I'll set and leave sound effects and UI at 100%. Okay, so that's what I'm going to program. But these percentages and these values that you set as the default can be changed according to how you feel is best. And then, of course, since we're providing the user the ability to change these configuration settings, they too can change it and it'll be saved. So we're going to use a couple different screens here. One script that we haven't used yet. Let's see. I'm going to close audio. I'm going to close some of these. I don't need door. I don't need most of these. I'm just going to keep a couple scenes. Keep a couple scenes open so we can test. We are going to want our pause menu. Another comment, I made this back when we implemented the pause menu. I think ideally these sliders, you're going to want the same thing somewhere on the title screen. Maybe you've got settings on the title screen as well. I'm not going to mess with that because this will work. And hopefully at this point in the tutorial, you guys are getting good enough that you would be able to figure out how to take this and make a version of that on your main screen, or convert this maybe to its own scene that you can then just copy and paste. If that's something that you guys can't figure out, though, go ahead and drop in the comments, or maybe join the Discord channel. If needed, I can make a short video about how to do that. But I'm going to come into our pause menu. I'm going to just go ahead and expose these. Oh yeah, we're on the right ones. We're on our music controls. So what we want is, we've got these sliders. We set them up in a previous video. So we've got music, sound effect, UI, and they've each been configured. Let's see, that they've got a minimum value of 0 and a maximum value of 1. The step right now is set to 0.05, and the value is set to 0.5, meaning the default value, okay? Just so that you can see where it is, it's halfway. I like setting the default to something in the middle so that you get like a nice preview of what the control looks like. But these values are all correct because we're going to be using this volume linear. So that's between 0 and 1, 1 being 100, 0 being 0. Okay, so that's the appropriate minimum and maximum values. And I think this step is good too. Okay, you could decrease it if you want. I wouldn't make it much smaller than that. We don't need any of these other things, page or rounded or anything like that. So we're obviously going to be needing to work on our pause menu script. And I'm going to close. We don't actually need our audio thing anymore. This can all happen independently of it. I'm going to just close a few things. We've opened a lot of stuff during the course of this video, but we're also going to be working in our save manager. So let's open that because I'd like to keep it consistent. You might even create a new thing that's like a configuration managing global type script, but I think our save manager is not terribly gross. So I think what we'll do is we'll just add in here, we'll add our configuration functions. Okay. There's just going to be two, a save and a load. But if these save and load configurations get out of hand for you, if you're saving lots of stuff, then it's probably going to make sense to move that off to a separate script, especially because we're going to be saving this to a config file type. It's going to be different than the JSON and the save data. Okay. But let's go to our pause menu and let's begin. I wish this was smaller, but let's go ahead and begin. I'm going to just move off of that for now. We're going to begin by looking at our show or setup the setup system menu. You say, oh, I have a comment here to set up the sliders. We never did this because we didn't have anything in place to really make it work, right? Because we didn't have the audio buses and we didn't even have audio to hear, so it would have been pointless. We're going to start by setting our music. So another quick comment. This code that we're doing right now affects the pause menu, which only displays when you load it. So what we're going to do is we're just going to grab the values of our audio mixer volumes and assign them as the values of these, okay? And then anytime we change it, we're going to just ask the save manager to save those values out to our config system. So we'll go music slider dot value, and we'll set it equal to, we're going to do this, we're going to go audio, let's see, audio server, like we were doing before, right? With the reverb effect. But we're going to use this get bus volume. There's a lot of get and stuff. So get bus volume. And you can see we've got in decibels or linear. We're going to work with linear because it's easier. And then the bus that we want to get for the music slider is 0, 1, 2. Okay. I'm going to go ahead and copy this. We're never really going to be messing with the effect pass volume level. Maybe you want to for some reason, for something you do, but that's going to be up to you. So the other ones are the sound effect and the UI bus. Of course, this needs to be SFX slider, and this one needs to be UI. Okay, so we'll just grab the linear volume from each of these and set it as the value of the slider. Okay. Now, if we run our game, there's going to be music playing. And they're full volume. They would have been at 50% otherwise, right? Because that was how we had them defaulted. Now, they don't yet do anything when we change them. So let's hook that up next. And notice we're calling this on the setup menu system. We're essentially just setting up how these things work. So next we'll say music slider dot value changed. So you notice that was a signal, right? That's a signal we have on our slider. So anytime that value changes, we can connect to that and we can create a function to handle it. So I'll say on music slider changed, and let's make this music one and hook it up, and then we'll do the other two. And I'm going to come down to the bottom. That's not very far away, is it? And how is this going to work? So when this signal is emitted, if we look at it, you can see that it emits a value as a float. Okay, so we need to make sure that we accept that argument. I'm going to call it V, and it's of type float. Okay, then all we need to do, what we can do is when it changes, we can go to our audio server, and instead of getting the bus volume, we can set it. It's basically the same thing. It's set bus. There's too many options. Volume linear. Okay, make sure we're using linear. You're not going to want to try and figure out dB for these UI. In fact, I could be wrong, but I'm pretty sure the linear was created specifically for the UI and these types of purposes. But maybe there's other general use cases like just general code that makes it a lot easier, at least for people like me. Dumb folk like me, but out there making potatoes and stuff. We ain't gonna know how to use none of them sliders. Okay, so we're gonna go. What do we want to do? We need to set so we need the bus index. If we're on the music bus, that's 2, and then the value is V. So that's pretty straightforward, right? Anytime that slider changes, update the bus volume. The other thing that we're going to want to do, and we're going to come back, is we want to save to settings. Okay, we'll come back for that. I'm going to go ahead and copy this. The music's going to be obvious because we're going to hear this. So now, in fact, yeah, before I copy and paste this, let's go ahead and test it. If I hit F5, yeah, you can see, there we go. I get all the way down, no music. Okay, so now the user can come in here, set their music how they want. Maybe they like it really quiet because it's, overwhelming, or maybe it's really crappy music, so they want it off. Please, stop the music. It's so crappy. Let's make another function for each of our other 2 sliders. So we'll have a sound effects slider and UI. Okay. Obviously, these are different. So the sound effect is bus 3, UI is bus 4. All right. Let me double check that. Pretty sure that's correct. Sound effect bus or UI. Okay. I want to do one other thing with these. In addition to saving the settings, I'm going to play a sound so that you have a sense for how loud that setting is as you're changing it, right? Because if you can't hear the difference, then it's hard to pick a volume. So let's start with the UI slider changed. We can just play audio. We can go audio dot UI focus change, that function. So anytime we change the UI slider, we can play that audio back. And then anytime we change the sound effect slider, I think we can do kind of the same thing, but let's play it in a spatial way. So we're going to say audio dot, oh shoot, this is actually kind of goofy. We don't have a reference to our player, do we? I considered including it, and then I kind of nixed it in the last second. Okay, hold on. Let's do this. Let's say play spatial sound, and we're going to just utilize the audio's, that same sound effect that we use for the focus change. So we're going to call audio.UI focus audio. Okay, that's going to give us that stream, that audio stream, so we can use that same little boom sound. We just need a position. I think we can just use the position of the pause menu, maybe. Let's just try that. Does it have a position? No, it doesn't. Hold on. Let's get the player. The player's centered. He's the best position to play it from, right? He's centered in the camera. That or the camera itself, actually. And that's not a bad idea, is it? Let's go ahead and do this. Let's just get, we'll just get the player position. We'll just get his position as soon as we start. So I'm going to say VAR player position. It's a vector 2. So on ready, we'll just do this up here somewhere. Let's get a player, VAR player. And it is possible that we wouldn't have one if you put some functionality like this somewhere like on your title screen. So you're just going to have a default maybe. Let's see, VAR player. I don't care. It's a node 2D equals. And then we're going to use, let's see, get tree dot find or get, yeah, I always do it wrong. Get first node in group player. Okay. And then if player, then we can set the player position equal to the player's global position. Okay, there we go. Quick little way to grab a player position. This isn't super necessary, but otherwise we don't really know where to play this audio to test it. So now that we've got a position, and that's not going to change because this is the pause menu, so the player is going to be where the player is going to be. We can just play the audio at his position. Okay, so let's go ahead and test our game. Go to the pause menu. Let's turn this music down. All the way, buddy. Huh? I'm not hearing any sound. Did I do something wrong? Let's check audio settings. Oh, well, we're doing one obvious thing wrong. We never connected to the change for those. Okay. Okay, so we've got music, sound effect. You can tell with these longer videos, I love making them, but my brain does start to melt partway through. So this is going to be our, we have a sound effects slider changed and a UI slider changed. Okay, let's test it again. Okay. Now if we go down to sound effects, that's a pretty quiet audio thing, but you can hear it, right? I mean, it's kind of quiet to begin with. But now we have separate UI and sound effects audio levels, and we can play back. Maybe you want to put a different thing in for sound effects when you're tweaking it, like one of the players, yeah, or something. I mean, whatever. Put whatever you want in there. Now that we can change it and it stays during the gameplay, let's go test this. Let's go ahead. I'm going to load my game. Do I have an open? Oh, no. Let's do this. Let's just make sure it works. I'm going to run scene 6. Turn music way down. I'm going to put sound effect in the middle too. So something like this. Sounds pretty good, right? Our UI is full audio. Music stays quiet. Okay, so that's pretty good. The last bit now is just to hook up this save to settings functionality. Okay, we're going to need to create a function in our save manager for this, and then we can come in here and hook it up. So we'll just make them right down here. I've already got a section, right? Maybe I make a region for this. It's not super necessary, but that'll be nice. Okay, here's our region. So we're going to have two new functions, I guess. We're going to have a save and a load. So we'll call one save configuration, I think is what we'll call it. And then we'll have a load. Okay. All right. So how do we do this? I mentioned we're going to be working with a new file type. So let's go ahead and define that. We're going to, not car, but variable, a new variable. We're going to just call it config. And I'm going to use this colon equals here. So this is equal to, there is just a built-in config file. So let's use this config file class, and then we can say .new. Go ahead and look at this. So we've got config file. It's a helper class used to store variant values on the file system using an INI style formatting. The stored values are identified by sections and keys. So you got a section name, you're gonna have a key and a value. So a lot like our dictionaries, just slightly differently formatted, right? It's not the same as a JSON as far as formatting, but it is basically the same in terms of what it stores. So you can see down here, we're basically implementing kind of the same kind of stuff they've got going here. What we need to do is we need to set the values and we need to save it. And before we do that though, let's introduce one new variable to our save manager script. Much like we've got a way with our functions to create like a file name. Where do we do here? Save file exists, get file, where does it get file name? Here we're saving it to user blah, 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 blah for our save files. Our config files function in a similar way. Go ahead and define a constant variable for this one though. And we'll just call this our like config file path. And it's going to be in our user folder again. So we'll do user :/ and then we'll just call it settings or config. So I'm going to just go, I think settings is good. Settings dot, and it is a CFG is the kind of the standard naming convention for that. So I'm just going to stick with that. Okay. So there we go. Now we've got a file path that we can reference. I'll come down here. When we save it, then we're going to go config dot, and then there's a save functionality, and we just need to provide the path. Config file path. Okay. We can look at that real quick. Saves the content of the config file object to the file specified as a parameter. And it will convert it to that in INI style structure. So this is actually pretty easy and carefree. In fact, the first couple Game Jam games I made just used config files for the save data because it was slightly quicker to get started, and then it worked, so I didn't even change it. Probably not recommended for a bigger game, but it couldn't hurt too much. Okay, so let's see. Let's set our values. So what we're going to do is we're going to, on the config file, there is just a function called set value, and you can see it gives us a section, key, and value. And if we go back to that config file, let's go to the top. So those values are the section, key, and value. So we just define those here. So all of these we're going to save in an audio section. So I'll just say audio. And then the next argument, this first one that we're going to save is our music. That'll be the key. And then what we can do is use this audio server. So we're kind of keeping some of these disconnected. You know, we're not using our audio system exclusively to set these. And maybe you want to in the future, but I'm just going to say get. Like it might be easier to just call audio.set volume and then pass in those values. I don't know. But here we're going to say get bus volume linear. Always working in linear. And this is bus 2. All right. Pretty straightforward, right? So that's just going to add a new line. And because we're going to have 3 and they all have this same audio as the section, you'll see how they're going to be grouped together. It's only going to create one section called audio. And then, you know, whenever you have this, if the audio section already exists, then it will just add the value to it. So we'll have SFX and UI. And of course, we need to update our bus parameter. This is 3 and 4. Okay. That's all we need. That is all we need to save a configuration. Let's go ahead and actually try and use this. So we have the function save configuration. It's part of our save manager. So if you go to the pause menu script here, anytime we change something, we can go to save manager dot save configuration. That's all we have to do. We're not even going to worry about passing in the values to save. I'm just going to put this in here. And let's go ahead and run our game. So we don't load it yet, so that's not going to work, but we should be able to set some values here, like music to whatever. Okay. And I just closed the game. We didn't do anything other than set the values. So now let's load up our user data folder. And we should have settings.cfg open in your favorite text editor of choice. Boom. Look at that. We've got an audio section and 3 values. So you can see our music apparently was 0.400004, and so on. Kind of cool, right? Kind of cool. Okay. Go ahead and we can just close that if we want to. But now all we need to do is be able to load those values, right? And the way that this is built, there's not a lot of knowledge between the two nodes, what's happening with each other. So like if we look at our pause menu, technically we can just load them and set the value and it's going to work, because our pause menu, when we look back at this setup system menu, it sets the sliders based off of whatever the volume is. So if we just load those settings when we start the game, then they'll be set appropriately. And then the only way to change them during the game is for the user to change them. And each change the user makes will save it back to the file. So they close the game and rerun it, and it'll open at whatever they last set. Does that make sense? Pretty straightforward, I think. So let's implement our load configuration, and then we just need to call it. Okay, this first line here, we can copy that and paste it. And then here's what we're going to do. This is, I'm going to make a little line. We say VAR ERR equals config dot load. So there's a load. And then what we want to load is we want to load the same path we're saving to, right? So this config file path. So create a new config instance. Try and load a config file from that path. And then we're just going to do a little check in here. If error does not equal okay. So if the file didn't exist, so this is just a way to error check. So if it didn't exist, then we can just return. And in fact, we might want to build something in here to set our defaults. I don't know. Let me think about that for a second. Yeah, I think so. We're going to go to our audio server. And instead of getting the bus volumes, we're going to set them. So we're going to say, let's see, audio server.set bus volume linear. Okay, the bus index for the first one is 2 because we're going to do the music. And what we'll do here is we're going to say config dot, and then there's a get value, just like we've used in previous save load. So what this allows us to do, in the case of a config file, we're doing the section, key, and default value, right? So the section that we're looking for is audio, and then we need to tell it the key. So it's going to look under audio, and then it's going to look for music, and then we can give it a default value. So maybe we want our default for our music to be 0.8. Okay. If for some reason that's not saved, and then I'm going to set these to 1 on these other two. And we just need to change this, right? So this is sound effects, SFX, and this is UI. Different buses, 3 and 4. Okay, there we go. So now we're able to set the volumes based on those. So if we run the game again, music should be quiet. Just kidding. If we were to have called load configuration, music would be quiet. So I'm just going to come in here to our ready function, actually, of our save manager. Just boink, load configuration. That's just all we got to do. Okay, now it'll work. So as soon as our game runs, okay, it set our volume levels. And then if we go into our pause menu, we can see what those levels are at. Okay. So there we go. We've got a settings system where we can save those values. Now, one thing I want to check that I didn't test prior to recording, and that's to see what happens if we don't have a config file. Because I think it's just going to return and we're not going to set our defaults is what I'm thinking is going to happen. So we might need to fix that in here. So here I am in my app user data for the project. I'm going to just delete settings. Okay, so we don't have a settings file. Let's see what happens when we load it. Yeah. It's like, hey, yeah, we didn't have one, return. So it didn't even get those defaults, did it? I think what we can do is we can just copy that and paste it in here in this if statement. Just make sure we get everything indented properly. But instead of using this get value, we're just going to give it a value. Okay, so we're just going to set our default right here. Yeah. Yep. This will work. I believe this will work. Okay. I want to make sure I didn't create a new file. Did I go into the settings menu? No. Okay, I didn't. Okay, so now we're going to set the volume. In fact, I'm going to exaggerate this. And in addition to setting it, let's just test that. It should be really quiet music. Yeah, so that worked. in addition to setting these, I mean, you don't have to do this, but we could trigger a save if we wanted to at this point, right? And that way it would create that config file. Alternatively, it'll just keep loading these defaults until the user makes a change. I don't think either of these is right or wrong until you add other code that maybe necessitates one or the other approach. Okay, so I'm going to go ahead and just run this. And now we'll see that I should have a configuration file that was created. Yeah, there it is. And it should have like 0.2 on the volume, right? Okay, so that's working. So you can determine how you want to do this. I'm going to set this back to maybe 0.8. So you save that. And I'm going to go ahead and delete this. Run my game. So there we have it. Now, I think the only things that I left out of this so far was maybe hooking up a few other sound effects. Like when we pause the game, maybe we want to play a sound effect there. You can utilize one of our existing UI sound effects and just play that. I got to turn this music down for me. Okay. And likewise in here, maybe when you hit escape to go back or back to map, maybe you want to play a different sound effect. So there's things that you can go through, add some polish, but it should be, again, pretty straightforward given the new system we've built. So thank you for following along. This is our penultimate episode in this chapter, the chapter about our game systems. And so coming up next, what I'm going to be working on is talking to you about how to export our project. That's going to be critical for the iteration process. So you can export your game, send it to a friend, have them play it, you know, give you feedback and things like that. And we'll talk a little bit about some of the other settings that you have as you export a game so that you can kind of just test and make sure everything's working. So thanks again for watching. Go ahead and drop a comment if you have questions or just want to help support me. Give the video a like, subscribe to my channel if you haven't yet. And as always, we'll see you next time.